have a division problem of polynomials. We're trying to take this cubic polynomial of 4 terms, 2x to the third minus 3x squared minus 18x minus 8, and divide it by this linear binomial x minus 4. This is a problem that sets up very nicely for this synthetic division process. I'm going to show you how that synthetic division algorithm works right now. So, this is an example of one where no powers are skipped. Notice the powers of x go 3, 2, and then 1, and then 0, like that. So we don't have any skipped powers here, so this is a pretty basic case. So to start off, when we set up a synthetic division problem, we are going to place a number over here in a little box. This is going to seem a little weird if you've never done this before. And that number that goes here in the box is actually the opposite of what you see here, where I see x minus 4, that negative 4 right there. I need the opposite of that, which would be positive 4. So that's the number that I'm going to place here in the box to start with. Then I list the coefficients of this polynomial that I'm trying to divide. The coefficients being the numerical factors of the terms. So I have 2, negative 3, negative 18, and negative 8. So I'm going to go ahead and list those across now. So 2, negative 3, negative 18, and negative 8. So those are the coefficients for that. Now, again, I'm still trying to set up the problem. I'm going to go ahead and draw a horizontal line here. It's going to be like our equals sign. It's going to be our bar we're going to cross. And we're going to be adding here in a moment, so I'm going to go ahead and put a plus sign right there. So at this point, we have the problem set up to perform this synthetic division algorithm. So now we're going to start to cycle through the process. The first thing that you do is you take the first coefficient and you just drop it straight down below the line. Once you've done that, you take the number in the box, which is 4, multiply it by this number down here below the line. 4 times 2 is 8. Write that answer under the next number. Add the column. Negative 3 plus 8 is 5. And then you just cycle through this process until you get to the end. Now I'm going to do the same thing now. I'm going to take the 4 that's in the box. I'm going to multiply it by this number down below the line. 4 times 5 is 20. Write that under the next number. And then add the column. Negative 18 plus 20 is 2. And then one more time. 4 times 2 is 8. Add the column, and we get 0. At this point, we've cycled through the algorithm here. But now what does this mean for us? Well, this thing right here, this number here at the end, is the remainder. So in this case, we got a remainder of 0, meaning that this linear binomial here actually divided into that evenly, making it a linear factor of the original polynomial over there. We'll talk about that a little bit more in detail. But we've got the remainder there, and then these numbers here, the 2, the 5, and the 2, are actually the coefficients of the quotient. We're going to go ahead and fill the powers back in, starting 1 degree lower than the problem originally was. Originally, I had a cubic polynomial here, so I'm going to start off 1 power lower than that, which would be a quadratic, or something of degree 2. So this is the coefficient of the quadratic term. So I would have 2x squared, and then this positive 5 here would be plus 5x, and this positive 2 here would just be plus 2. So this right here is what we would call the quotient. So we perform the division. When you do a division problem, you get a quotient and a remainder. The quotient here was our answer to the division problem. The remainder in this particular one was 0. So that's how you perform this synthetic division process, from the setup and cycling through it all the way down to getting your quotient and the remainder. I believe the problems I have set up on the assignment for my class ask for the quotient to be answered in one box, and then the remainder to be answered in another box on the computer program that we're using. So hopefully that helps with that.